Hello everyone. So from this video we will try to understand the basic concepts of decision tree from a classification machine learning perspective. So let us just start. So by the end of this video you will be able to understand the basic concepts of decision tree as a classifier, learn about the greedy algorithm, learn about some terms known as information gain ratio and split info. So what is a decision tree basically? So on the basis of a decision, it will take a split, and until it reaches the pure nodes, it will continue splitting. So basic example of an OR gate. So you see in Y we have, so you can basically understand this is the truth table of an OR gate. So in the Y column you can see initially we have 3 true and 1 false. So first we classify whether x1 equals to true, x1 equals to true. So on the basis of that we have 2 true and 0 false, and then see, so x1 equals to true in both of these cases. We have y both are true, so there are 2 true and 0 false. And in x1 not equals to true means x1 equals to false, we have 1 true and we have 1 false. So we have 1 true and 1 false. So this node is known as pure node because it has 0 false and all the classes are giving as true. So basically if we do a majority vote like 2 true, so true will win. So this is a, so this gives, and it will win by any means, there is no chance for false to win since this is complete 0, and hence we will call this as a pure node. So this is not a pure node because if we do a majority vote we will end up in getting a tiebreaker, right? Because both are true and 1 false. So now what we do, our split will be x2 equals to true. So if x2 is true, if yes, we have 1 true. In if is x2 is not true, we have 1 false. So out of these two, first we have taken the x1 is false. In entire of this split, x1 is false. Now we see x2 equals to true in one case and false in the other case. So whenever it is true, x2 equals to true, we are getting true, and if x2 equals to false, we are getting true under the case of x1 equals to false. So this way we create a decision tree basically, and this was a small data set. Similarly we can apply it for even a large data set, but very often it could lead to overfitting. So we will understand how to get rid of those overfitting. So as of now we just understand this concept, and this is majority vote concept. We may reach the end of a leaf by doing majority vote and not deciding to go for the split. Let us understand this. So let us say we have 50 applicants, out of which we are saying yes to an interview call to 10 of them, and then we are saying no to the interview call to 40 of them. So initial accuracy, so if we simply do majority vote without any split, so if we simply do without with a majority vote, we will get no. So this, so we can, the worst thing we can do is tell that an applicant will not be getting selected. So if we always tell that an applicant would not be getting selected, our accuracy is 80%. Now we do some splitting on the basis of a great intern. If our applicant is having a great intern, then in that case we are giving 8 yes and 7 no. So yes to 8 of them, and no to 7 of them. And if they are having not a great intern, then we are having 33 no's and 2 yes. So after this split, the accuracy is 82%. So how it is happening, we will see that. So you see here, so what we can tell basically, if you are not a great intern, then there is most probable chance that you will not be getting selected. So if we do majority vote here, we get some accuracy of 33 by 35, something like that. And if we do majority vote here, we get yes. So this way the majority vote thing works. So now greedy algorithm. So actually, to understand this first, let us go back to the first slide. So you see here, x1 equals to 2 was the first decision, was the first condition we split upon. So we could also have taken x2 equals to 2 first, and then x1 equals to 2 the later on. So in a complex data set, there will be many features. So how will we understand that on what feature we need to split first? So how will you understand that? So what greedy algorithm says is, suppose in the previous example we take other features to split upon for splitting on more than one feature. So how to decide which features to split upon? So I told you the greedy algorithm says that whichever initially will give me the best accuracy, I will choose that first. So first I do a split, then I see on the basis of feature X I get this much accuracy initially, and on the feature of basis of feature Y split I get some another accuracy. Whichever accuracy is the highest, I will choose that split first. So these are the steps of the greedy algorithm basically. If a node is pure, output the only class. If no feature is left to split upon, output the majority class. If none of the above two, find the best feature to split upon. After that, recursively call on the splits. So the deciding parameters. So we decide which feature to split upon based on the accuracy. We will also see these terms known as information gain, gain ratio, and Gini index. So what is this information gain? So we have something known as entropy information. So information at a particular step is basically defined by minus p log p. So remember, this log is base 2. So in logistic regression also, whatever logarithm we have used, all are base 2 logarithm. So if a node consists of 9 yes and 20 no, then the entropy info of that node would be minus 9 by 29 log 9 by 29 minus 20 by 29 log 20 by 29, and this log all has the base 2. So let us say that entropy info of is 0.86 for an initial node containing 40 elements. So for 40 elements initially we have 0.86, and somehow information of n we have 0.6, 0.4 and 0.8. Then information gain is given by minus of the weighted average of all the entropy info. So I am doing the weighted average for 20 by 40 into 0.6, 5 by 40 into 0.4, and 15 by 40 into 0.8, and we are adding the initial info. So initial info we had 0.6, so the entire information gain we will have something like this. So generally we pick the feature with the maximum information gain. So information gain is basically something like how much information are we gaining after performing a particular split. If we are gaining more information after performing some particular split, we will choose to split upon that feature only. So what is this gain ratio and split info basically? So the information gain tend to favor very small splitting of nodes, may lead to overfitting. So if on the basis of information gain, there is a chance that you will it will lead to overfitting. So we take these two, gain ratio and split info. So gain ratio is something called information gain by split info. So we are just dividing in the information gain by something known as split info, and split info is calculated with this formula. So in each of this node we are just doing the weighted average of the logarithm term. So let us just take an example directly. So for 50, suppose there are two splits, 50 is split into 25 25, or 50 is split into 149. So initially the split info will be 25 by 50 minus of 25 by 50 log of 25 by 50, minus again the same term will come because both are 25, so we are just multiplying it by 2. So with log 2 base 2, if you calculate, you will get split info as 1. So now if you get split info of this thing, you will get 0.1215. So therefore split info is favoring unbalanced splitting. So you can see why split info is less here. If split denominator is less, gain ratio will be more. So if more gain ratio, we will tend to favor those splitting. So always, due to the split info factor, it always tends to favor the unbalanced splitting of the nodes. So this thing you need to keep in mind. So yeah, that's all from this video. Next video we will just extend our knowledge to of this decision trees. Till then, thanks a lot.